Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on regression and correlation, and we're using some alien data. And I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos, and this is part 3 of our video series on this PowerPoint. And we just finished up our first example in part 2, and now we're going to talk about some of the things that can go wrong as we do the calculator. And these are some of the most common errors. One of the most common errors is a dim mismatch, and what that means is a dimension mismatch. And this means there are a couple of things that this could mean. One is that the lists are different lengths, and so when you see that and you get that, go and check your list under Stat and Edit and make sure that you've put them in the correct, you've inputted the numbers correct and that they're the same exact length. And the other problem that could be is that you've put your list in like list 2 and list 3, and it was trying to do the linear regression on list 1 and list 2. So the other thing is to check to make sure the correct lists are selected in your stat plot, because that's a dimension mismatch. That's where it's trying to plot or calculate on things that aren't the right size or matched up correctly. Another problem that happens is that points do not appear properly on your scatter plot. No points on the graph, or not all the points appear, or they're crammed together. Check the stat plot and plot 1 to see if it's set correctly, and then do zoom and zoom stat to get proper axis values, or you could reset your window by your own for the appropriate axis values, and those are some corrections. A third thing that happens is that the line does not appear on the scatter plot when you get to that portion. And if that's the case, the linear regression equation is not in y equals. Did you forget to put y1 in the linear regression when you did it, or did you press enter and then go back and select 1? So redo the linear regression with y1, comma y1, and then press enter. Or you can select y equals and just type in the equation by hand. Just type in your linear regression. And yes, it's okay if you've rounded it to 4 decimal places as opposed to typing in the entire equation like it does when it stores it. We're not worried about the rounding there. That will be the same. Now let's look at example number 2. And let's work it together. In this case, we have female alien data and the heights of the females and their weights in pounds. Our heights are 5.32, 5.44, 5.51, 5.71, 5.76, 5.89, 5.95, 6.03. The weight in pounds is 108.1, 109.6, 109.0, 110.5, 111.2, 112.4, 112.3, 113.2. And we're going to first make a scatter plot of the data, and then answer the question, does the general trend of the data appear to be linear? And we won't go through the details because you should be able to use your calculator to do that, but here is the scatter plot and the screenshot of that scatter plot. And does the general trend of this data appear to be linear? With the height in feet and the weight in pounds indicated on our axis, yes, it does appear to be linear. The B part, what is the correlation coefficient? Well, going through your steps on the calculator, you should get this screenshot here as your correlation coefficient and your linear regression equation information. And what is the correlation coefficient? It is R, and R is 0.9805. Let's look at question C. Based on the correlation coefficient, is there evidence of a linear relationship? And justify your answer by stating the critical value from the table and explaining how you used it. If you will count, you will see that you have 8 paired data. Not the number of numbers, but the number of paired data. So n equals 8. That gives us from our table a critical value of 0.707. The correlation coefficient from the previous screen is R equals 0.9805. Since the absolute value of R is greater than the critical value, there is a general linear trend, there is evidence of a linear relationship. Yes. Part D, find the percentage of variability explained by a linear relationship. Remember from the very first video that we had this phrase, and again, not all teachers will use this measure, but since our calculator gives us this information, it's not hard to find. It's listed as a percentage. Find the percentage. So we take our R squared and multiply it by 100. We're moving our decimal over 2 places. So we take this, round it to 4 decimal places, gives us 0.9614 times 100, gives us 96.14%. Excuse me. And that's 96.14% of the variability in the data can be explained by the linear relationship between the height and weight of our female aliens. Question E. Based on the scatter plot and the correlation coefficient, is it appropriate to use the linear regression equation to make female weight predictions within the range of the given height values? Well, the scatter plot trend appears to be linear, and using the critical value, the absolute value of R is greater than the critical value of 0.707. So yes, it is appropriate to make predictions using the linear regression equation. So find the linear regression equation. We'll remember our screenshot from previous, and our linear regression equation is y equals ax plus b. It's even given there in our screenshot. And we will fill in the a and the b. A being 6.9066 rounded to 4 decimal places. So that gives us y equals 6.9066x. And our b being 71.4111. And that gives us our equation, where x is the height in feet of our female aliens and y is the weight. G, make a scatter plot with the regression line, and does the regression line follow the general trend of the data? So we can just press graph, and our calculator should give us that line drawn through our data. And yes, the regression line does follow the general trend of the data. H, predict the weight of a female alien that is 5.7 feet tall and show the work. And we can use either the regression equation or the average y value, whichever is appropriate. In this case, because it does have a linear relationship, we will use the regression equation. Recall that y equals 6.9066x plus 71.411. That is the regression equation we found in our previous work. And we have two ways that we can use that. We can plug in the 5.7 feet tall, which is our x, and we can plug that in for x and use the calculator to calculate that and calculate our arithmetic. That gives us y equals 6.9066 times 5.7 plus 71.411, which is 110.77872, or approximately 110.8 pounds. Or we can use the shortcut method if we have it stored in y1 by going y1 parentheses 5.7 end parentheses, and the calculator will automatically plug 5.7 in for the x in equation y1. And that also gives us 110.778, or approximately 110.8 pounds. Either way is correct. Let's talk about the slope. What is the slope of the regression line? Recall that our regression equation is y equals 6.9066x plus 71.411. That means that the slope is 6.9066. Interpret the slope by filling in the blanks with the sentence with weight, pounds, or feet. Weight, height, pound, or feet. So let's think about it. Slope is the change in y over the change in x. So it's the weight over the height, because weight is y and height is x. So if the slope is 6.9066 over 1, that's y over x. So the y is 6.9066 and the x would be 1. So if the blank increases by 1, so that would be the x. So that would be the slope is rise over run. 6.9066, I didn't think she had this here, and she does, is the change in y over the change in x. 6.9066 over 1. So that means that 6.906 is the y, which is weight, and the height, which is 1. So if we're increasing by 1, we're talking about 1 is the height. So if the height increases by 1 what? Well, 1 is measured in feet. So 1 foot, then the what? Well, this is talking about the 6.9066, so that's the weight increases by 6.9066 what? What is it measured in? By 1 pound. So every time the height increases by 1 foot, the weight increases by 6.9066 pounds. J, the y-intercept. What is the y-intercept? The y-intercept is where the line would cross the y-axis. Recall our equation, y equals 6.9066x plus 71.4111. So our y-intercept is 71.4111, or if we wrote that as an ordered pair, would be 0, 71.411. X would be the height, or 0 feet. The Y is the weight, or 71.411 pounds. A height of 0 feet is beyond the range of the data. Also, there's no such thing as an alien with a height of 0 feet. That would be no alien. Therefore, there is no meaning to the y-intercept. And that is why it would not be appropriate to interpret the y-intercept for this data. And that is a good place to stop, and we will begin example 3 in the next part of this video series.